Okay. Welcome to the class, students. Good evening. So today in this class, we are going to discuss some of the important questions related to the topic organic chemistry. Okay, we are going to understand about few of the important questions completely related to the topic organic chemistry here. So that is all about hydrocarbons and biomolecules. Part 1. Now let us look at the first question here under this topic. So the first question is here. What is iodized table salt? An element, a compound, a heterogeneous mixture, a homogeneous mixture. Okay, now let us look at the answer. The right answer here is option D, a homogeneous mixture. Okay, homogeneous mixture is the one where there will be composition, the mixture. In a mixture, all the components, they would have got uniform throughout the solution or throughout the mixture. Okay, they would have composed uniform throughout the mixture. So any such mixture that can be called as homogeneous if there is uniform composition there. Okay, so when we are looking at this table salt, iodized table salt, okay, it is completely homogeneous mixture because iodine is uniformly distributed here in the table salt, that is in sodium chloride. Okay, moving to the next question, which is a mixture of potassium nitrate, powdered charcoal, and sulfur called? Glass, cement, paint, gunpowder. Okay, let us look at the answer here. The right answer is option D, gunpowder. Okay, so gunpowder is a mixture of powdered charcoal, sulfur, as well as potassium nitrate. So when we are looking at this here, powdered charcoal as well as sulfur. Okay, these two acts as a fuel. Okay, these two acts as a fuel here. Whereas this potassium nitrate that we have here, this acts as oxidizer. Okay, it acts as oxidizer so that it will provide the oxygen molecule to this mixture, which is necessary for it to combust, okay, for the combustion to happen. And due to this reason, okay, because of this property, the amount of heat as well as the gas volume that it generates, that is the gunpowder generates during this condition. So here the gunpowder is widely used as a propellant. Okay, we will use this as a propellant here in firearms, rockets, fireworks, mining, as well as road building. So in all of these conditions, in these cases, we will use this gunpowder as a propellant because it can produce a lot of heat as well as gas volume. It can increase the gas volume there. Okay, moving to the next question now. Consider the following statements. The purpose of adding sodium sulfate and sodium silicate to washing powder is to keep washing powder dry, to maintain the alkalinity of the powder. So which of this statement are correct? Option A, only one. Option B, only two. Option C, both 1 and 2. Option D, neither 1 nor 2. Okay, let us look at the answer. Yes, the right answer is option C, both 1 and 2. Okay, let us look at these two statements. So when we are adding this sodium sulfate and sodium silicate to the washing powder, okay, in a washing powder that we use as a detergent at our house, okay, there is a mixture of both sodium sulfate and sodium silicate. So both of this together is necessary in washing powder to keep the washing powder dry and also to maintain the alkalinity of the powder. Alkaline solution is the one which will get dissolved in the water. Basically, it should be a base, right? The bases which will dissolve in the water, that can be called as alkalines, right? Alkaline. So now here we have this washing powder, which is an alkaline because it will get dissolved in the water easily, right? So when we are adding the silicate salts, okay, sodium silicate salts, so it is used as a detergent, synthetic detergent, right? Synthetically using some of the chemicals we will prepare it in the laboratory. So this has proved it is very beneficial because here the silicates that we will use in washing powder, that is required to form a precipitation. Okay, it has to form a precipitate in water. When we are adding this to the water, it will form the precipitation. Okay, so that if there is any impurities, that is we can soften the water by removing the calcium ions as well as magnesium ions. Okay, calcium and magnesium ions are the one which will cause hardness to the water. But when we are adding this washing powder to the hard water, so now the hard water can be converted into soft water because the silicates which are present in the washing powder will start precipitating these ions, calcium as well as magnesium ions. So when it settles down, so precipitates are formed only when it is not dissolved in the water. If it is not dissolved, then definitely it will settle down in at the bottom of the beaker. So here, if it is settling down at the bottom of the beaker, by the process of filtration, we can easily separate this, right? So now, finally, so obtained water will be soft water, which can be used for our daily usage. Then we can use the same for all the different activities that we carry out. So apart from this, now the soluble silicates which are present in the water, okay, that is in washing powder, so they contribute to detergents as a cleaning aids, processing aids, as well as corrosion inhibitor. It will not allow it to corrode. Okay, it will allow it to clean the substances, the surface of the cloth that we are using. Okay, we can easily clean it. A cleaning aids where there will be soluble silicate provide alkalinity because it has to get dissolved there, right? And also promote soil suspension. If there was any soil particles present in that liquid or a solution that we have taken, it will get suspended from that media. Clear? And sodium sulfate. So this is all about sodium silicate. It has a major role here in washing powder. Okay, but when we are looking at the sodium sulfate, it doesn't have much role. It doesn't have any active role here in washing powder. It is simply added as a filler in detergent powder. That is in washing powder. Sodium sulfate is just added as a filler. It doesn't have any major role in washing powder. Okay, just like as in the case of in medical tablets, they will use some of the fillers just to fill the surface. So similarly, even here in washing powder, sodium sulfate is the one which is added as a filler. But sodium silicate, which is present in this washing soda, it has a major role in cleaning the substance, cleaning the surface. Clear? Okay. Moving to the next question now. In a fuel cell driven vehicle, the energy is obtained from the combustion of methane, hydrogen, LPG, CNG. Okay, let us look at the answer. The right answer is option B, hydrogen. Okay, so the energy here in the fuel cell driven vehicle, the energy is obtained from the combustion of hydrogen gas. So hydrogen gas, when it gets combusted here, on combustion, it releases the energy, right? And this is what is used as a power to provide it for the electrical motors. Okay, to run the electrical motors here, the power provided by this hydrogen gas is utilized. So fuel cell vehicles use hydrogen gas to power an electric motor. So unlike the conventional vehicles, so other rest of the vehicles they will usually use this gasoline or diesel to run, right? So usually to transport gasoline or the diesel, these are the fuels that they will usually use. But when we are concentrating on this fuel cell cars or the trucks, they combine both hydrogen gas as well as oxygen. Hydrogen and oxygen both are combined here to produce electricity. Okay, so here in fuel cell cars, so that is what we have here, right? Fuel cell driven vehicles, they will use both hydrogen as well as oxygen to produce electricity. So this is the one which is used to run the motor of the vehicle. Okay, so hydrogen is used in fuel driven vehicles as an energy power supply. Move to the next question now. What is kiss of death? A flower whose smell was the basis of a discovery on smell that led to award of 2004 Nobel Prize in Medicine. A protein degradation mechanism whose discovery ultimately won the scientist the 2004 Nobel Prize in Chemistry. A good wine flavor working on which scientist won the 2004 Nobel Prize in Chemistry. A network in brain associated with smell whose discovery let the scientist win the 2004 Nobel Prize in Physiology and Medicine. Okay, now let us look at the answer. The right answer is option B. Okay, a protein degradation mechanism whose discovery led ultimately won the scientist the 2004 Nobel Prize in Chemistry. So usually these three scientists, here we have three scientists, Aaron Chichenover, Avram Hersko, and Irwin Rose. So these were the three scientists. They have combined, because of their combined work for a longer period of time, they finally awarded the Nobel Prize in Chemistry 2004 for helping us to understand how our human body gives kiss of death to rope proteins. Okay, so our body can produce this rope proteins which are completely ubiquin mediated proteins. Okay, ubiquin is one of a chemicals in our body. So mediated protein, ubiquin mediated protein. So that is what we call it as kiss of death. So this is actually required in our body to fight against the diseases. So serious diseases such as cancer. To fight against these diseases, we require ubiquin mediated proteins, which are also known as rope proteins. And that was finally discovered by the scientist here. And for their same work, they also got this Nobel Prize in Chemistry. Okay, it is one of a protein degradation mechanism. Clear? Moving to the next question now. Consider the following statements. All hydrocarbons show phenomena of isomerism. The members of a homologous series have same chemical and physical properties. Cyclic hydrocarbons are saturated or unsaturated organic compounds that contain ring of carbon atoms. Synthetic detergents are sodium or potassium salts of long chain carboxylic acids. So which of the above statement are correct? Option A, only C. Option B, only D. Option C, A, B and C. And option D, A, C and D. Okay, let us look at the answer. Here, the right answer is option C. Okay, option A, that is only C. Okay, so this statement is the correct statement here. So cyclic hydrocarbons are saturated or unsaturated organic compounds that contain ring of carbon atoms. So usually the cyclic hydrocarbon groups, okay, hydrocarbon groups which are usually cyclic, they are usually saturated or it can be unsaturated organic compounds. They usually contain a ring of carbon atoms. There will be a carbon atoms which is usually attached with hydrogen atoms. Okay, where the valency is usually filled with hydrogen. So now let us consider the rest of the statements here. All hydrocarbons show phenomena of isomerism. No, it is not a right statement, because all hydrocarbons do not show isomerism. But what is this isomerism? So isomerism is a phenomenon where more than one compound have the same chemical formula. Okay, if there are two different compounds, that is called A and B. Okay, see these two compounds, they may have same chemical formula, but they have a different structure. Okay, they may have same chemical formula will be same, but still the structural arrangement of these two different compounds will be definitely different. That is what we call it as isomerism. Okay, but when we are looking at this hydrocarbons, definitely these hydrocarbons are not, that all the hydrocarbons does not show isomerism. Okay, same isomerism. That is the structure as well as the molecular formula usually differs. It will never be the same. It will not always be the same. Moving to the next second statement here. The members of homologous series have similar chemical as well as physical properties. Okay, what is this homologous series here? Homologous series is a family of hydrocarbons, a group of hydrocarbons with similar chemical properties who share the same general formula. They usually share the same general formula. General formula will be the same, okay, which belong to a same chemical, so same family, and they also have the same chemical properties. Since they have the same chemical property, their general formula will also be the same. Okay, homologous series, they have only the same chemical properties, but not this physical property. Okay, chemically they may be same. Okay, their structure may be same, but not physically. Okay, homologous series, they have same similar chemical formula. Clear? Similar chemical properties. Moving to the last statement here. Synthetic detergents are sodium or potassium salts of long chain carboxylic acid. So usually these detergents, okay, synthetic detergents are the one which we will use some of the chemicals to synthesize that in a laboratory. So these detergents are the one where there will be sodium salts. Okay, sodium salts of long chain aliphatic or aromatic sulfonic acids. Okay, not a carboxylic acid, it is sulfonic acid. Okay, sodium salts of long chain aliphatic as well as aromatic sulfonic acids. So usually sulfonic acids, sodium salts are used as detergents here. But what do you mean by aliphatic or aromatic here? Aliphatic are again a group of hydrocarbons where it always usually differs based on the number of carbon atom chains they contain. Usually they are classified as alkanes, alkenes as well as alkynes. Okay, based on the number of bonds that can form in between the atoms. Now when we are looking at this aromatic are usually unsaturated compound by one or more planar rings. Usually there will be one or more planar rings which are attached with each other, just like this. Okay, if we consider this as a benzene ring, so here we can see the attachment of one more planar ring, right? So there are one or more planar rings which are attached with each other by covalent bonds, and that is what we call it as aromatic compound. Okay, so when we are looking at this detergents, there will be a mixture of sodium salts with sulfonic acids. Okay, it is not carboxylic acid. Clear? So out of all the statements here, we have the C statement, which is the right one. Okay, cyclic hydrocarbons are saturated or unsaturated organic compounds that contain ring of carbon atoms. Okay, so here in this rings, there will be carbon atoms attached. All these are called hydrocarbons. Moving to the next statement now. So which one of the following is not present in cement? Clay, alumina, alum, gypsum. Okay, let us look at the answer now. Right. So the right answer here is option C, alum. Okay, alum is not present in cement. Usually gypsum is added. Okay, gypsum. So your copper sulfate dihydrate. Okay, hydrated copper sulfate solution here. That is what is gypsum, which is added to the cement here in a calculated quantity in order to adjust the rate of setting of the cement to allow the cement to get settled. So here this gypsum is added, which will usually turn into harder mass, right? Alum is usually not present in cement. So apart from this, the rest of the chemicals which are generally present in the cement are calcium, silicon, aluminium, ferrous. So all of these are the chemicals usually present in the cement. Okay. Apart from this, some of the common materials which are present in this cement are limestone, shells, chalk, clay, slate. So blast furnace slug. Okay, the slug is the residue that we will get it out of it, right? The waste particles. Along with that, silica, sand, iron ore. So all of these are the extra common materials which are usually present in this cement. Okay, moving to the next question now. Match list 1 with list 2 and select the correct answer from the codes given below. Morphine, here we have antiseptic, sodium, alloy, boric acid, analgesic, German sealer, kerosene oil. So option A, 4312, option B, 2431, option C, 3142, option D, 3412. Okay, let us look at the answer. So the right option is option D, 3412. Okay, let us look at this now. Morphine. Okay, here we have this morphine. It is used as analgesic drug. Okay, analgesic drug that is used to relieve severe pain. Usually during surgeries, this is what they will provide, morphine. It is to relieve the pain. Okay, the next here we have is boric acid. Boric acid is also known as orthoboric acid. So it is one of a weak acid and that can be used as antiseptic or insecticide. Okay, boric acid is used as antiseptic solution. So next here we have sodium. Sodium is the one, okay, sodium is the one which is stored in kerosene oil. Sodium, since it is highly reactive metal, it cannot be placed in the natural surface, that is in contact with the oxygen, or we cannot even place it in water because it is highly reactive, which can easily react with air as well as water, and it can easily catch fire since it is the strongest reducing agent. As in when we expose it to air, it can quickly oxidize. It will get quickly oxidized as well as it will start catching fire. It will react with the oxygen and catches fire. To prevent all of this, we will usually store the sodium, potassium there in kerosene oil. Okay. And the next one here we have German silver. German silver is an alloy. Okay. Here the German silver, which is also known as nickel silver, it is copper alloy. So along with this copper, there will be a presence of nickel and also zinc. Okay. Copper, nickel and zinc. All of these are the mixture that we can find it here in German silver. The major component of this German silver is copper, where the minimal quantity in specific ratio, nickel as well as zinc is also added to make it an alloy to get the desirable properties in that. Okay. So morphine, it is used as analgesic, sodium stored in kerosene oil, boric acid used as antiseptic, German silver, it is an alloy of copper, nickel and zinc. Moving to the next question now. So the correct order of these fuels in terms of their calorific value is in increasing order is hydrogen gas, kerosene oil, charcoal, wood. So option A 4321, option B 4231, option C 1234, option D 1324. Okay, let us look at the right answer here. The right option is 4, 3, 1, 2. Okay, in increasing order. So when we are arranging all of this in increasing order, the first here we will get is wood, followed by charcoal, then kerosene oil, then finally we have hydrogen gas, right? So what is this calorific value here? Calorific value of a fuel is the quantity of heat it is going to produce when we combust this at a constant pressure as well as under normal conditions. Okay, so when we are taking a small amount of the fuel, if it burns, okay, and the amount of after combustion, the amount of fuel that it can produce after combustion, that is what is known as calorific value. And for usually different gases, different elements, it usually differs. The calorific value will also remain different. So when we are looking at all of these examples, options that they have given us here, hydrogen gas is the one which has highest calorific value. Okay, it has highest calorific value, followed by kerosene oil, then charcoal, then wood. So wood has least calorific value, whereas this hydrogen gas has highest calorific value. Okay. Calorific value is nothing but the fuel that it is going to burn. Even after burning, after combustion, the amount of heat it is going to produce, that is known as calorific value. Moving to the next question now. Among the following fuels of energy, which is the most environmental friendly? Ethanol, biogas, CNG, hydrogen. Okay, let us look at the right answer. The right answer is option C, CNG, compressed natural gas. Okay, it is basically based primarily on methane. So the major content present here in the CNG is methane. Okay, CH4. And it can be combusted without releasing too much carbon into the atmosphere. So when we are combusting this CNG, that is it can also be used in automobiles. So nowadays, this is what most of the vehicles they use. Okay, CNG gas. So when we are combusting this, it will release only minimal amount of carbon into the atmosphere. So when there is a minimal amount of carbon released into the atmosphere because of the combustion of the CNG, it doesn't pollute the atmosphere much, right? So air pollution can be minimized when we are using the CNG, and it is more environmental friendly fuel, okay, which can be used alternative to that of petroleum as well as gasoline, where this petroleum and gasoline can produce more amount of carbon, and that can be released into, that is then released into the atmosphere, which causes pollution. Okay, so instead of all of that, so we can encourage the usage of CNG. Moving to the next question. The metal compound commonly found in sindoor or kumkum is based on tin, lead, copper, zinc. Okay, let us look at the right answer. Here, the right answer is option B, lead. Okay, the metal, that is the lead, is the compound which is commonly found in sindoor or the kumkum. Okay, so here when we are looking at this, lead, which will usually combine with the oxygen to form lead tetroxide. So here we have a formula of lead tetroxide, which is commonly known. It is commonly known as red lead, because that has a pigment which usually provides red or orange color solid. Okay, it is the one which will produce red color or the bright red or orangish color solid, and that is the one which is used as a sindoor. So nowadays that is available in the market. So they will add lead tetroxide to this sindoor to provide a bright color to that. Okay, it is here the lead tetroxide is one of the inorganic compound. Okay, it has a pigment, and this pigment can also be used in manufacturing of batteries, rust-proof paints, okay, primer paints. Usually the color, the pigment is required there in paints. So even lead tetroxide can also be used there. Okay, moving to the next question now. The gaseous fuels burn without producing smoke, has low calorific value, are easy to ignite, have high calorific value. Select the correct alternative. So the option A and B, option B and C, option C and D, option D and B. Okay, let us look at the right answer. The right answer is option A. Okay, it is C and D. Sorry, it is option C and D. So this is the right option. So here the gaseous fuels that we use, they are easy to ignite, as well as they also have high calorific value. So these are the properties which make us use more gaseous fuels for all the automobiles, even for industrial purpose. Okay, because they will ignite easily. That is, the ignition temperature is very less for this. So with the normal, minimal at the room temperature, it can start burning. It will start burning. Okay. So now when we are looking at this option, have high calorific value. That is, when we are burning, say for about some example, some quantity of a fuel, it can produce more amount of energy. Okay. By combusting a minimal quantity of the substance, it will also provide, it will undergo complete combustion and produces large amount of heat energy. So it has a high calorific value. Okay. So when we are looking at the rest of the properties of this gaseous fuel, they are usually easily transportable. We can easily carry from place to place through the pipelines, right? Easily it can be transported to different places through pipelines. And also while burning, it will not usually leave any residues. Okay, after burning, just like a paper or a plastic cover, plastic polythene bags, if you burn it, definitely it will release. It will leave out some of the residues, chemical residues, right? But when we are burning these gaseous fuels, it doesn't leave any residues even after burning. Okay, that is one of the property of this gaseous fuels. Along with that, it also has low ignition temperature, which can burn easily. Okay, this can burn very easily since it has low ignition temperature, and also they have high calorific value when we compare it with that of solid or any other liquid fuels, so that it can also provide more amount of heat energy, which can be efficiently used for all the purpose. Okay, moving to the next question now. Soap helps in cleaning clothes because the chemical of soap change. It increases the surface tension of the solution. It absorbs the dirt. It lowers the surface tension of the solution. Okay, let us look at the right answer here. So the right option here is D, option D. It lowers the surface tension of the solution. So when we are using this soap in cleaning clothes, usually it lowers the surface tension of the solution that we are using. Okay, soap helps to lower the surface tension of the solution. The soap gets stick to the dust particles and grease so that it can be removed easily by the action of the water. Usually these soap molecules, they have a long chain of carbon and hydrogen atoms. Okay, soap molecules, they have a large chain of long fatty acids chains of carbon as well as hydrogen molecules. So when we are applying the water here, so it separates the water molecules. This long chain of fatty acids which is present in the soap can separate easily. It can separate. So the water molecules easily, that is hydrogen and oxygen, it can easily separate it. So this is the one which creates the distance between the water molecules. So water molecules will move apart from each other, right? So when the distance between them is increased, okay, when we are increasing the distance, that lowers the surface tension. So this is how it works. As in when we are increasing the surface distance between the water molecules by applying the soap, it lowers the surface tension so that all the soap molecules will get stuck to that of dust particles as well as the grease, oil particles. If it is any stains which are present on the surface of the cloth, so that will get stuck to that soap molecule, right? So that it can be removed easily from the cloth by the action of the water when we are applying some of the water here. Moving to the next question now. Which of the following is not a nitrogen fertilizer? So calcium cyanide. Next here we have calcium cyanamide, ammonium nitrate, urea. Okay, let us look at the right answer here. The right answer is option A, calcium cyanide. Okay, calcium cyanide is not actually used as a nitrogen fertilizer. We know that fertilizers are the one which are required to grow the plants, right? Fertilizers are the one which will artificially increase the amount of nutrients present in the soil so that it is required for the well growth of the plants. But when we are preparing these nitrogen fertilizers, usually this calcium cyanide is not actually added. But apart from this, the rest of the options that we have here, calcium cyanamide, you have to know the difference between these two. Calcium cyanide, and this one is calcium cyanamide. Okay, calcium cyanamide is one of the major nitrogen fertilizer used. Okay, to prepare the nitrogen fertilizer, calcium cyanamide is the one which is majorly used. Apart from that, ammonium nitrate as well as urea. So all of these are the nitrogen fertilizers which are added to make a fertilizer required for the growth of the plant. Okay, so except calcium cyanide, so all are nitrogenous fertilizers here. Moving to the next question now. Match column 1 with column 2 and select the correct answers giving the code given below the columns. Fertilizer, king of chemicals, sulfuric acid, basic, lime water, magnesium hydroxide, milk of magnesia, potassium nitrate. So option A tells us that A, we have to match it with S, B with P, C with Q, and D with R. Option B, A with R, B with P, C with Q, and D with S. Option C tells us that we have to match A with S, B with Q, C with P, and D with R. Option D, A with S, B with P, C with R, and D with Q. Okay, let us look at the right answer here. The right option is option A. Okay, A with S, B with P, C with Q, and D with R. So let us look at this now. Fertilizer. Here, potassium nitrate is the one which is used as a fertilizer. Okay, upon dissociation, here the potassium nitrate, that we will use it as a fertilizer. Upon dissociation, that is when it gets dissociated. Okay, the compounds which we have here, that is potassium and nitrogen, it gets dissociated, that is separated. We will get potassium and nitrogen, which are the major two nutrients required for the well growth of the plant. So in a combined form, potassium nitrate, we are going to use this as a fertilizer, which increases the crop yield. Okay, because these are the major nutrients required for its growth. So next we are looking at sulfuric acid. Sulfuric acid is also considered as king of chemicals. So why do we call this sulfuric acid as king of chemicals? Because using this sulfuric acid, it is one of the strongest acid that is available. Okay, sulfuric acid, hydrochloric acid, all these are strongest acids. But when we are concentrating on the sulfuric acid here, using this acid, we can derive the rest of the acid. Most of the acid can be derived using this sulfuric acid. And it is also responsible for the production and also has been used to estimate the economy of the country. Because based on this, we can prepare most other acids, right? So based on the sulfuric acid, even our country's economy can also be estimated. Okay, so that is the reason it is also called as king of chemicals. So when we are looking at this lime water, it is basic because lime water is nothing but calcium hydroxide, right? CaOH2. So calcium hydroxide, which is basic in nature. Okay, calcium hydroxide, which is also known as lime water. In chemistry, we call it as lime water, calcium hydroxide. So which is basic in nature because they show all the basic properties. Now we have milk of magnesia. Milk of magnesia, which is also known as magnesium hydroxide. Okay, magnesium hydroxide is a chemical name, but the common name that we have here is milk of magnesia, which is a weak base. So this is the one which is added as antacid to reduce the acidity in our stomach. If an individual is suffering from the acidity, usually doctor will prescribe a tablet called milk of magnesia, which is rich in milk of magnesia. Because the magnesium hydroxide, since it is basic in nature, once we take in this tablet, that enters our stomach. So the more HCl secretion in our stomach can be neutralized by the action of this milk of magnesia, so that it will finally relieve the pain by neutralizing the acid contained there. Got it? Moving to the next question now. Match each item in column 1 with appropriate item in column 2. Melamine, non-sticking cookware. Nylon, easily biodegradable. Teflon, appears like silk. Cotton, flame resistant. So select the correct alternative. Option A tells us that 1 with D, 2 with C, 3 with A, 4 with B. Option B, 1 with A, 2 with B, 3 with C, and 4 with D. Option C, 1 with B, 2 with A, 3 with D, and 4 with C. Option D, 1 with C, 2 with D, 3 with B, and 4 with A. Okay, let us look at the answer. Right answer here is option A. Okay, 1 we had to match it with D, 2 with C, 3 with A, and 4 with B. So let us look at this now. Melamine. Okay, melamine is one of the plastic. It is one of a type of plastic, thermosetting plastic. Okay, which has a basic property of flame resistant. So usually this melamine is the one which is used to coat the uniform of fireman. Okay, fire person, their uniform is coated with this layer of a thin layer of melamine because it is flame resistant, and this property is necessary for them since they will work usually in fire accidents, right? So melamine is one of a thermosetting plastic. It is an example of thermosetting plastic. So now when we are looking at this nylon, it appears like silk. Nylon is also called as artificial silk. We know that natural silk, that we will get it from the silkworm, secretion of silkworm, right? Proteinaceous silkworm. So now, here we have nylon. It is one of a synthetic fiber. Okay, we will not get it naturally, but using the natural source, that is wood pulp, we can artificially synthesize it by applying some of the chemicals. We can process this chemically, right? So this nylon has the same properties as that of silk. So we can say that it is also an artificial silk. Teflon is the one which is used to coat the non-sticking cookwares. Okay, some of the cookwares, they usually coat the surface of this pan, for example, pan or the kadai, tawa that we use into cooking purpose, right? for all of this purpose. So usually they will coat this layer, inner layer, with this Teflon, because it is the one which has a property of non-sticking nature. So this is the one. Okay, here polytetrafluoroethylene. Teflon is also known as polytetrafluoroethylene. So here in this polytetrafluoroethylene, there is a high stronger bond between carbon as well as fluorine atoms. Carbon and fluorine atoms, between them there is a stronger bond which is completely non-reactive in nature. And due to this high bond strength, they usually doesn't stick with each other. Okay, even if you add oil, it will not stick to that. Okay, so usually Teflon is the one which is used to make non-sticking cookwares. Cotton is a natural fiber that is easily biodegradable. So all the natural fibers that we will get it from plant source as well as animal source, like cotton, jute, silk, and even next year we have sheep wool. Okay, so all of these are biodegradable since they are natural product. Okay, moving to the next question now. So here we have a hydrogen has a molecular formula of C6H12. It does not react with hydrogen to give C6H14, nor it does not react with chlorine to give C6H12Cl2. So now the hydrocarbon C6H12 is a saturated hydrocarbon, an unsaturated hydrocarbon, an open chain hydrocarbon, a cycloalkane. So options are A and B, option B, C and D, option C, D and B, option D, A and D. Okay, now let us look at the right option here. So the right option is option A and D. Look at these options here, the statements that we have here. Option A, it tells us that the molecular formula of an hydrocarbon that we have here is a saturated hydrocarbon and also a cycloalkane. But how can we tell this? So let us understand that here, the hydrocarbon that they have given us here with a molecular formula of C6H12. We know that it does not react with hydrogen to form this C6H14, right? Nor it does not even react with chlorine to form C6H12Cl2. So now the hydrocarbon that we have here, C6H12, it can be unsaturated or it can be saturated or it can also be cyclic hydrocarbon. Now out of this, let us look what is the right option that we can select here. Okay, given that it will not react with hydrogen as well as chlorine to form this respectively, right? So it cannot be unsaturated now. So when it is not reacting with hydrogen or the chlorine to form the respective compound, definitely it is not unsaturated, right? It should be saturated hydrocarbon now. Let us look at this now. And even it cannot be open hydrocarbon. The hydrocarbon that they have given us here, it cannot be unsaturated and it can also not be open chain hydrocarbon. Okay, so we can rule out these two options now directly. Since it is not reacting with chlorine or the hydrogen, it cannot be unsaturated because it is already saturated. That is the reason it doesn't want to react with hydrogen anymore and even with chlorine, since it is already saturated hydrocarbon now. So when we are looking at this open chain hydrocarbon, okay, because since it is not satisfying, okay, it doesn't satisfy this, so it cannot be even open chain hydrocarbon. Okay, it will usually not satisfy the general formula that we have here, CnH2n. Okay, so here we have CnH2n plus 2. Okay, it can neither be open chain hydrocarbon because it is not satisfying the general formula of all the hydrocarbons, that is CnH2n plus 2. It is not satisfying this. So it cannot even be open chain hydrocarbon. So we can directly rule out these two options that we have here. So looking at the rest of the options, that is a saturated hydrocarbon. Yes, it can be a saturated hydrocarbon. And when we are looking at this last, okay, so here we have C6H12. It is cyclohexane. It is a structure of cyclohexane that we have here. Okay, it is a cycloalkane. It satisfies these options here. The saturated hydrocarbon as well as cycloalkane. Here you can see the cyclic structure of this alkane group, right? Where there is saturated hydrocarbon. So all the bonds are filled with hydrogen bonds here. So hydrogen atoms here, right? So the option that we have here is saturated cyclohexane. Okay, so both A and D options are right out of this. Moving to the next now. C11L methyl methionine is used for brain tumor and parathyroid imaging, stomach analysis, bone imaging, live imaging. Okay, let us look at the answer here. So C11L methyl methionine, it is the one which is used for brain tumor as well as parathyroid imaging. So here it helps us in position emission tomography. Okay, that is in PET, position emission tomography. So here this C11L methyl methionine is the one which is used as PET in medical analysis. It is basically to differentiate and to locate the primary brain tumor, the tumor which is present in the brain. Okay, this is the one which will help us to detect the brain tumor in an individual, in a patient there. And also to monitor the therapeutic effect. Okay, during the therapy that the doctors will usually provide to a patient, the effect of this on the tumor, whether it is degrading or is it enhancing or is it remaining the same. To analyze all of this, we require this C11L methyl methionine to analyze this brain tumor in an individual. Okay, by this position emission tomography. Okay, it will help us to know the position of the tumor in a brain. Moving to the next question here. Pyrethrin used in mosquito coil is obtained from a seed plant, an insect, bacterium, and a fungus. Okay, let us look at the answer. Here, the right answer is option A, seed plant. Okay, pyrethrin, it is one of a compound which is used in mosquito coil. The mosquito coil that we will use to kill the mosquitoes, to prevent the mosquitoes that enters our house, right? So here this, in the manufacture of this mosquito coil, pyrethrin is one of a chemical compound which is used. And that is again obtained from seed plant. Okay, here it is one of a natural plant that is derived from the substance which comes from the flowers of chrysanthemum. Okay, chrysanthemum cineraria folium, it is one of a flower. So from its derivative, we will get this pyrethrin. Okay, it is one of a chemical, so which is then utilized here in the manufacturing of mosquito coils. Okay, it is completely from a seed plant. Moving to the next questions, okay, from the chrysanthemum plant here. So we will get this pyrethrin, which can be used to make this coils. So in which of the following functional group isomerism is not possible? Alcohols, aldehydes, alkyl halides, cyanides. Okay, let us look at the right option here. The right answer is option C, alkyl halides. So here the isomerism is not possible here in alkyl halides. Apart from this, rest of the option, alcohols, aldehydes, as well as cyanides. So in all of these cases, we can observe the formation of isomerism. But what is this isomerism? Isomerism is a condition where in a compound with same molecular formula but different structural formula. They have different structure, but the molecular formula will always remain the same in between the compounds, two or more compounds. Okay, such compounds can be called as, so that process phenomenon we call it as isomerism. And this phenomenon of isomerism can be found here in alcohols, aldehydes, as well as cyanides, but not in alkyl halides. Okay, so apart from this, here when we are looking at this alcohols and ethers, aldehydes and ketones, cyanides and isocyanides, all these are functional isomers. Okay, they undergo isomerism, that is, they have a similar molecular formula, but the structure of them is completely different from one another. Okay, it is because there is only one way to attach a halogen to a carbon chain. We have one single bond. There is only one single bond present, so through which a carbon halogen will get attached to that of carbon chain, long chain carbon. Okay, long carbon chain. So to this end, with only one single bond available, this carbon, that is the halogen, will get attached to this carbon chain. Okay, halogens cannot form more than one bond. That is one of a condition here. Okay, when we are comparing it with that of the common organic compounds, definitely they can form double bonds, triple bonds, right? But these halogens cannot form multiple bonds to the carbon. So that is one of the reason only the halogens are the one which can be considered as this here. Okay, it can undergo isomerism, but not this alkyl halides. Moving to the next question. Polycot is a mixture of cotton and nylon, polyester and nylon, polyester and cotton, wool and polyester. Okay, let us look at the answer here. Polycot, here the right option is option C, polyester and cotton. Okay, here polycot is a blended fiber. Okay, the blended fiber is the one where we will use two or more different fibers and we will blend it together to form a single yarn. Okay, we are going to select two different, for example, let us take two different fibers which are of cotton. One is a synthetic and one more is a natural one. Two different fibers we are going to combine together. We will blend it together to get a single fiber out of it. So which will have a desirable character. So we will get both natural properties as well as synthetic properties in the so obtained final product, final fiber, right? So that is what we call it as blended fiber. And here polycot is one of a blended fiber where there is a mixture of polyester as well as cotton. Cotton is a natural fiber, whereas this polyester is synthetic. Using chemicals, it is made, right? So finally, in this blended fiber, that is in polycot, we will get the advantage of both properties of cotton as well as polyester. Okay, mixed cotton, that is what we can say. Moving to the next question. Match list 1 with list 2 and select the correct answer from the codes given below. So German silver, here we have tin, solder, nickel, bleaching powder, sodium, hypochlorine. So option A, 1, 2, 3, 4. Option B, 2, 1, 3, 4. Option C, 1, 2, 4, 3. And option D, 2, 1, 4, 3. Okay, now let us look at the options. The right answer is option D, 2143. Okay, when we are looking at this German silver, okay, this German silver, there is a mixture of sodium. It usually looks silver in color. German silver, it is also known as nickel silver. Okay, it appears usually silver in color, and it is an alloy of copper, nickel, and zinc. Okay, so here we have this option. German silver, we can match it with nickel because nickel is one of a alloy of this German silver. Okay, we will combine this copper, nickel, as well as zinc in definite specific ratio to make this German silver. It more or less appears like a silver. Okay, so now next we have solder. Solder is it is one of an alloy of tin. Okay, so this we can match it with tin here. Tin, antimony, copper, and lead. So all of these are combined in specific ratio to get the solder. It is one of an alloy of all of this. Okay, tin, antimony, copper, and lead. So all of these are mixed together to obtain desirable characters and properties there in this alloy called solder. Moving to this next, that is bleaching powder. Bleaching powder consists of chloride. Okay, so calcium chloride and calcium hypochlorite. So these are the salts which are present here in bleaching powder. Okay, so here chloride is the one which basically acts as a bleaching. It has a bleaching property here. It is on the basis of chlorine, available chlorine here, which is liberated when it is treated with dilute acids. So if you are treating this bleaching powder, basically it has a chlorine within them, right? Bleaching powder which acts as a, so here the chlorine which acts as a bleaching agent, when it is treated with dilute acid, it will start liberating. Okay, and it is also then used to make a paper pulps as well as fabrics and also for sterilizing substances. Okay, so apart from this, so your bleaching powder can be matched with chlorine, and this bleaching powder, since there is a presence of chlorine, this is the one which is used to purify the water that we will drink here, right? The water in there in purification, water treatment plant, they will add this chlorine because it has a bleaching properties. It will kill all the germs present in the water. Okay, so next here we have hypo. Hypo can be matched with sodium, because hypo, which is nothing but sodium thiosulfate. Okay, sodium thiosulfate, which is also known as hypo. Here the chemical formula, chemical name of this is hyposulfite of soda. Okay, it is commonly called as hyposulfite of soda, which is where the chemical name of this is sodium thiosulfate, which is required in photographic fixation. So usually the photographers, when they click the picture, they will develop the image, right? After developing this image on exposure to the light, during negative copy, obtaining negative copy, they have to fix the image, photographic image onto the sheet, right? So during this process, they will use this sodium thiosulfate, that is hypo solution, to fix the photographic image. Okay, so silver, nickel, solder, it is an alloy of tin. Okay, one of the alloy here is tin. Bleaching powder, it consists of chlorine as a bleaching agent, hypo sodium thiosulfate. Moving to the next question now. CNG used in automobiles to check pollution mainly consists of CH4, CO2, N2, and H2. Okay, let us look at the answer. Here the right answer is option A, CH4, which is nothing but methane. Okay, the major component of the CNG is methane, which is approximately about 95%. Okay, 95% of our CNG, that is compressed natural gas, consists of this methane. So one of the major gas present here, which acts as a fuel here. So along with this methane, there is also presence of 4 other hydrocarbons. Okay, here we have 4 other hydrocarbons such as ethane, which is about 2.5%, propane 0.2%, butane 0.06%, and pentanous plus decane. It is approximately about 0.02%. So in this natural gas, that is compressed natural gas, there is a mixture of all of this hydrocarbon in the respective proportions. Okay, but the major component of this gas is methane, and that is the one which is responsible for the combustion to happen. Okay, along with all of this, it also consists of, okay, this natural gas also contains small amounts of nitrogen, that is approximately about 1.6%, carbon dioxide, it is of 0.7%, and hydrogen sulfide gas, it is of trace. Okay, trace, minimal, very minimal quantity of it is present. Along with that, even water droplets are also present, but it is in very trace amount. We cannot even count that, calculate that. Clear? So the major compound of natural gas is methane. Moving to the next question. So match list 1 with list 2 and select the correct answer using the code given below the list. So John Dalton, under this list 2, here we have the law of definite proportions by volume. John Prost, law of multiple proportion. Anthony Lavoisier, so law of definite proportion by weight. Joseph Louis Gay, so Lusac, so these two scientists, law of conservation of mass. So option A tells us that 2314. Option B 2431. Option C 1432 and option D 1342. Okay, let us look at the right answer here. The right answer is option A, 2314. Okay, let us look at this now. John Dalton, he gave us the law of multiple proportions. Okay, John Dalton gave us the law of multiple proportion, and Joseph Prost, he proposed law of definite proportions by weight. Anthony Lavoisier, he proposed the law of conservation of mass. So Joseph Louis Gay and Lusac, so they gave us the law of definite proportions by volume. So all of these laws apply to our chemical reactions, where it has to participate in chemical reaction, the reactants which are participating in the chemical reaction. So the different laws given by the different scientists here. Okay, moving to the next question now. Which one of the following is used in the preparation of antiseptic solution? Sodium nitrate, potassium nitrate, iodine chloride, potassium chloride. Okay, let us look at the answer. The right answer is potassium nitrate. So here we have this second option, option B. Potassium nitrate is the one which is used in the preparation of antiseptic solution. Okay, iodine is one of a powerful antiseptic solution which is present here. And it is used in the tincture of iodine, which is 2 to 3% of iodine solution. And it is mixed with alcohol water. Okay, that is iodine solution. Moving to the next question. Consider the following. Crude oil is a direct source of asphalt. Here we have paraffin wax, fatty acids, gas oil. Which of the above are correct? 1 and 2 only, 2 and 3, 1 and 4 only, 1, 2 and 4. Okay, let us look at the right answer. The right answer is option D, 1, 2, and 4. So all these three, that is asphalt, paraffin wax, and gas oil. So all these three are the direct source of crude oil. Okay, so asphalt, which is nothing but a mixture of aggregates, blinder as well as filler. Okay, binder, filler, so all of this. So asphalt is used as a aggregates, binder as well as filler. Along with that, paraffin wax as well as gas oil, which is nothing but diesel. So all of these are obtained from fractional distillation of crude oil. So crude oil that we can extract it from earth crust, right? As a petroleum product, where there we will this petroleum, we will get it in the form of crude oil. So when we are subjecting for distillation, there in petroleum refinery, so here we will get this crude oil as a, crude oil is the basic common natural substance, natural liquid that we will get. Okay, out of this we can extract all of this as paraffin wax, gas oil, even diesel, bitumen, coal. So all of these can be extracted by fractional distillation here out of this crude oil. Okay. Moving to the next question now. The monomer or monomers used for the synthesis of N6 are hexamethyl aldane, hexamethyldiamine and adipic acid, caprolactam, urea and formaldehyde, phenol and formaldehyde. Okay, let us look at the answer. Option B is the right one, caprolactam. Okay, caprolactam that we have here is the right option. So this is one of a monomer which is used for synthesis of nylon 6. But why do we require this nylon 6? Caprolactam is the one which is used in the manufacture of nylon 6 fibers, and these fibers and resins are the one which are basically used in textile industry. They have a more popularity now since we will use it in textile industry. So to manufacture the brush, bristles, as well as synthetic fiber. So there we will use this caprolactam. Okay, it is used to make this nylon 6 fibers. So when we are looking at the rest of it, so here we have hexamethylene, diamine and adipic acid. Okay, N6 is made from only one kind of monomer called caprolactam. Okay, it is only one monomer that we are going to use called caprolactam is the only monomer used to make nylon 6. So nylon 6 and 6. So we can see that there are two different monomers which are present, right? So two monomers, that is adipolychloride as well as hexamethylene diamine. Okay, adipolychloride, that is adipic acid as well as hexamethylene diamine, these two are used to make nylon 6,6. So it is polymer, right? So two monomer units are added together to make this nylon 6,6. So when we are looking at the next, nylon 2, nylon 6 is a polymer, copolymer. So here we have one monomer as well as which is attached with one more monomer here, two different monomer units. So where there is a mixture of glycerin and amino caproic acid. Okay, there is a mixture of glycine as well as amino caproic acid. So glycine as well as amino caproic acid. So these two are the monomer. Here we have one and one more. These two are combined together to make this nylon 2 and nylon 6. So all of these are different types of fibers that we use. Okay, we know that nylon is one of a synthetic fiber. Okay, different types, that are basically different structural types of this nylon fibers are used for different purposes as a synthetic fiber, basically in textile industry. Okay, moving to the next question. So here we can see the structure. Okay, caprolactam. So where the nylon 6 is the one which is made out of the single monomer, and here we have adipolychloride. Okay, adipolyl chloride, and the next here is hexamethylene diamine. So all of this three here, which are used to make the different types of nylon, the synthetic fiber. So these chemicals are basically used to prepare the synthetic fibers. Moving to the next question now. So the new strain of bacteria produced by biotechnology in alcohol industry is Escherichia coli, Saccharomyces cerevisiae, Bacillus subtilis, Pseudomonas pudica. Sorry, Pseudomonas Pudica. So here it is Pseudomonas Pudica. Okay, let us look at the right option here. The right answer is option D. Okay, Pseudomonas pudica. Okay, it is a pudica, Pseudomonas pudica. It is one of a species of Pseudomonas group. So this is a new strain that we got. It is one of a bacterial strain which is produced by biotechnology in alcoholic industry. So when we are looking at this, so it is one of the new strain produced in biotechnology. By using biotechnological techniques, we have got this new strain out of this bacteria. Okay, it is one of a Pseudomonas species. So when we are looking at this Escherichia coli, so all of these are the different bacteria that we have: Escherichia coli, Saccharomyces cerevisiae, Bacillus subtilis, Pseudomonas species. So all of these are the species of different bacteria. So when we are considering this E. coli or Escherichia coli, they are usually gram-positive bacteria. Sorry, gram-negative bacteria. So facultative as well as anaerobic bacteria, and usually they are rod shaped. This is how the shape of this bacteria will be. Okay, and also coliform bacteria. So usually they enter warm-blooded organisms lower intestine. So warm-blooded organisms, including us, right? Even we are warm-blooded organisms. It can enter our, somehow if it enters through the food, it can enter and occupy the space there in the lower intestine of our body. Okay, this bacterium. When we are moving to the Saccharomyces cerevisiae, so it is also known as baker's yeast, which is one of a fungus. So we cannot consider this answer here, since it is not a bacteria. Okay, it is a fungal species. It is a fungal species which is also known as baker's yeast. Clear? Used in basically used in baking industry. Next here we have Bacillus subtilis. So it is also known as hay bacillus, or we also call it as gross bacillus. Okay, this is gram-positive bacteria, catalase positive bacteria, as well as found in the soil. They are usually found in soil. And usually the ruminants as well as the human beings, basically ruminants are the one which will feed upon the grass-eating animals, right? So from the soil, it may enter our body, human being body as well as ruminants body. Okay, ruminants are the one like cow, sheep, goat, buffalo, grass-eating animals usually. So they enter the gastrointestinal tract of an organism, that is in ruminants as well as human beings, and it can cause different diseases there, Bacillus subtilis. Okay, now when we are looking at Pseudomonas pudica, okay, so Pseudomonas pudica, these are the Pseudomonas species. And finally, in the year 2014, taxonomically, they have confirmed that they are Pseudomonas species itself. They have developed the strain, and the strain, based upon the strain, they identified and classified it under a taxonomy that it also belongs to Pseudomonas species, one of a species of Pseudomonas after getting a strain. So these Pseudomonas species are the one, they are usually gram-negative bacteria, rod shape. The shape of them will be usually rod in shape. Okay, saprotrophic soil bacterium. They are also present in soil, anaerobic species, coliform bacteria, and they enter warm-blooded organisms. And in turn, it can affect our lower intestine if it enters our body. It has a major role in alcoholic industry. Okay, so which is a one, since it is anaerobic bacteria, it can carry out the fermentation process easily. Usually fermentation is required there to produce the alcohol and all, right? So there it has a major role in alcoholic industry. Now, when we are looking at the next question, which of the following chemicals is used in foam fire extinguishers? Aluminium sulfate, copper sulfate, cobalt sulfate, nickel sulfate. Okay, let us look at the answer. So here in foam fire extinguishers, it is one of a type of extinguishers, fire extinguishers. Okay, to cut off the attack of fire accidents. So there here in foam fire extinguishers, we will use aluminium sulfate. So this is the right option here. Okay, aluminium sulfate. So basically there in foam fire extinguishers, they contain usually sodium bicarbonate. Okay, aluminium sulfate is used in foam fire extinguishers. So this foam fire extinguishers which contain sodium bicarbonate as well as aluminium sulfate in separate receptacles. There will be separate chambers, separate jars where one of the jar is filled with aluminium sulfate and one more, the next jar is also filled with sodium bicarbonate. Okay, NaHCO3, sodium hydrogen carbonate. So now when they are separated into separate receptacles, so when there is a fire attack, they will usually break out the jar. One of the jar, if they break it out, so if the glass jar is like this, fire extinguisher, cylinder, ammonium sulfate. So during the fire accident, there will be presence of plunger. It will destroy this glass jar. Okay, it will break the glass jar so that the solution that we have here will get mixed with that, mixed with the remaining solution in the jar. So when these two different solutions, that is aluminium sulfate as well as sodium bicarbonate, which was actually present in the separate receptacle, now combine together. During this combination, there we can observe the reaction that is happening. Okay, when they will mix, they will start forming a foam. Foam is created, and this foam in the form of bubbles. Okay, bubbles of carbon dioxide. Foam is released in the form of bubbles of carbon dioxide. So when there is a release of this carbon dioxide, definitely we can cut off the fire, because carbon dioxide definitely does not allow, it does not help in combustion process. Okay, so we can cut off the fire spread there by applying this carbon dioxide layer. It covers the layer completely like a blanket, where it will not get the oxygen in contact with that of electrical circuits if you are spraying it there. Okay, so this is how it works. So in this class, you have learned about we have discussed some of the important questions which are completely related to the topic organic chemistry, and it's all about hydrocarbons as well as biomolecules, right? We have discussed about few of the most important questions which are related to this hydrocarbons, types of hydrocarbons, and all about biomolecules, right? So thank you for attending the class now, students.